To allow us to detect a ground fault on the 110-volt DC system, we normally use center point grounding. Here's a typical battery and load configuration. Here is the ground detector connected to the center point of the battery. We provide a high-value resistor in series with a ground fault detector to limit the fault current to milliamps should a ground fault occur. The ground fault meter is simply a milliammeter, which detects the flow and direction of the current. During normal operation, the current flows from the positive side of the battery through the load and back to the negative side of the battery. Should a fault occur on the positive terminal, some current will start flowing through the ground detector, and back to the center point of the battery. Only a few milliamps will flow because of the resistor in series with a ground connection. The ground fault detector will detect the flow of current and indicates a fault on the positive terminal. For a fault on the negative terminal, the current will flow in the opposite direction, and the ground fault meter will indicate a fault on the negative terminal. Having this type of earth fault detector is a good way of monitoring the health of the DC system. For major battery earth faults, the fault current generated should be sufficient to operate the MCBs immediately. The earth fault monitor will also trip the circuit breaker. For minor earth faults, an alarm will be generated and the battery left connected. The engineer can then trace and repair the fault at a later date. It is quite common for older substations to have a number of minor battery earth fault alarms caused by the insulation on the cables and equipment failing as they age. These will be very difficult to trace, and many may be left in place until the DC system is fully overhauled.